Hi guys, my name is Luke, and in this video I'm going to show you how to make the sonar goggles that Switch made for Loop when he was trapped in the mine. Here I've got an example of how they might look, but before we do that I'm going to read you the part of SwopBots where Loop is down in the mine and thinks there's something else in the mine with him. As the sense of danger had passed, Luke found he was already getting bored. He was hungry and cold, and he couldn't wait for Moby to get through to take him home. As the drilling sound was getting louder, Luke decided to walk further back and try to explore a little using the goggles. Even that became boring, however, as it was always the same. Rapid beeping left and right due to the walls, slower beeping above him due to the ceiling, and no beeping ahead of him. He sat down and began to run his fingers over the goggles, trying to work out how they had been made. Although he would never have admitted it, he was kind of jealous of the things Switch was able to do. He knew quite a bit of coding himself, which he mostly used to make his own games, but there was no way he was ever going to be as good as Switch. He guessed that's why he didn't work as hard as he could have done, and preferred to run around playing games. That was at least one thing he could do better than Switch. Beep. That's odd, Loop thought. Must have been because I put my fingers in front of the sensor. Beep, beep. Loop had moved his hands away from the goggles. He was staring straight down into the blackness of the tunnel ahead. Beep, beep, beep. How can they be beeping? There's nothing there, just empty tunnel. Beep, 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 beep. It's like something's coming towards me, Loop thought. He stood up and started walking backwards. The beeping slowed down, indicating he was further away from whatever object was causing them to react. He stood still and waited. Beep, beep, beep. The beeping was becoming more rapid. Something was moving towards him. Loop turned and ran back to the hole, waving his hands, hoping Moby would spot him. So here I've got everything ready to make my sonar goggles. Of course I have my Arduino board, then importantly my sonar sensor. Now to connect everything up I'm using 4 jumper cables, the kind with pins on one end and the open space on the other end. So I've got 4 of those. Now mine are still connected together, but that doesn't really matter if they're connected along this way, if they're joined together or not. Then I've got the buzzer that will let us know how close we are to things, and because I'm going to be walking around with it, I need to use the battery clip. So my battery clip, which will connect to my 9-volt battery. So that's everything you need to get started, and now I'll show you how we make it. Now to begin with, we're going to have a look at our sonar sensor. It looks like it's 2 eyes on here, but actually what we've got is more like a speaker and a microphone. So over on this side, you'll see we have a letter T, that stands for trigger, and over here we have an R, which is the receiver. So what's happening here is the trigger is giving out our sound wave. It bounces off an object and the receiver is listening for that to bounce back. In the middle we've got these 4 pins. We have VCC, that's our power, our trigger, so that's our sending out our signal here, echo, that's our receiver listening for the sound wave to bounce back, and our ground. Now we need to connect these 4 pins to our Arduino board. So I've got my board here. The power and ground I'm going to use over on this side of the board, where we've got our 5 volts and then a ground. So let's connect these up first of all. Now I'm going to take my 4 cables here, and because mine are joined together I'm going to plug all 4 of them in together. So just like that. And then I'm going to use these colors to help me remember which is which. So let's start with some power. That's our VCC, and that's this outer cable, the blue one. So I'm going to go to the other end, find that blue cable, and I'm going to connect that to the 5 volts power. Now this is blue, but the color doesn't matter. That's just a plastic case, and that can help you remember which one is which, but the color doesn't make any difference to the way it works. So the only important thing is that, well, let's come out, let's put it back in again. The most important thing is that this cable is the one that is connected to VCC here. And now I need to do my ground. So that's this side, that's an orange cable for me, and I'm going to connect the orange cable, move these others out of the way, the orange cable to the ground, and that is next to the 5 volts. So make sure you can see that. My blue cable is going to 5 volts there, and the orange one is going to ground, and that's my 2 outside. VCC goes to 5 volts, and this ground goes to ground on the Arduino board. Excellent. So we've got power and ground set up. Next we need to deal with the echo and the trigger. Alright, so we can see here that it's the yellow cable that's going to echo, and these echo and trigger pins are going to be plugged in to one of our numbers on this side of the board. Now when it comes to doing the code, it's going to be important that we know which number we've used for the echo and which for the trigger. Because I've given you some code, I can tell you that I have used the number 8 for the echo, so that's our number 8 here, and number 9 for the trigger. So I need to get my echo, that's the yellow one, into number 8. So let's do that first of all. Get my yellow cable, and I'm going to put it in to number 8, just like that. And well, we only have one left, so that must be my trigger, and that's going to go into number 9. Okay, so we've got the echo to number 8, trigger to number 9, and we'll just double check. So the yellow is my echo, and down here the yellow is going to number 8, the green is into number 9, and we can see on the sonar sensor green is my trigger. So now we have this sonar sensor all connected up with power and ground, with our echo and trigger, and the next step will be to get the buzzer in place. Here I've got my buzzer, and just like the LEDs, we've got 2 legs, a positive and a negative or ground. So the longer leg is the positive and the short leg is for ground. Now in this code I've already used the number 11 pin. Let's get these out of the way. I've used number 11 for our buzzer, so the long leg is going to go to number 11, and I've chosen that because if we put the long leg into number 11, then the short leg reaches perfectly into the ground. So let me just get that lined up. So just like that. So you can see from this angle again, that longer leg is going into number 11, and the short leg perfectly reaches the ground. We're not using a breadboard with this because we want it to be portable, and it works well plugged in directly just like that. So we're almost finished. We've got our sonar sensor, we have our buzzer. Next step will be to connect to our computer and to upload the code to the microcontroller here. So here I've got my USB cable already. First I'm going to plug this into our board. So I'm taking the square end and just plugging it in like that. And then I'm going to take the USB end and plug that into a USB port on the computer. Now we can see things appear to be working. We've got the on light coming on there. So if you've got some lights on, hopefully everything will be okay. Now we're going to head over to the computer and have a look at the code. So we've got our code open. Might seem a little bit complex. It's actually not that bad. Depends how familiar you are with coding in general and Arduino code. I'm just going to run through it now, give you a quick overview of the main parts, and there'll be another more in-depth tutorial for those that want to know. Otherwise, if you just want to get the game up and running, then all you need to do is open this code and run it, and perhaps skip ahead to the part where I show you about connecting the battery. But for now, let's have a little look at the code. So we have our echo and trigger pins here. So trigger pin is sending out the signal, echo pin is receiving it, and we've got our buzzer. That's all that we're using for this. This next part, this is our distance. So remember, it's going to tell us how far away an obstacle is. So we've got our long range set at 75. These numbers can obviously be changed. So if you're going to do anything with the code, I recommend you change these numbers, set it up for how you want it to react. Medium 2, so that's medium range is 50. Another medium range is 25. So basically we've got one distance set at 75, a little bit closer is 50, a little bit closer is 25, and the lowest is 0. Then we just skip ahead to our setup here, where we've got our pin mode. The trigger is an output, the echo is an input, it's receiving that signal, the sound that's bounced back, and we've got our buzzer, which of course is an output. So pretty standard stuff here. And then into our loop. Now this part is the part that deals with the actual sonar. So what does it do? Well, it sends out a signal on the trigger pin. Well, first of all, it turns it off. So make sure that trigger is off for 2 microseconds, a very short time. Then it turns on that trigger, sends out a signal for just 10 microseconds. Then it turns it off. So we're turning this trigger pin, make sure it's off, then on, then off. Then with the echo pin, we're looking for that pulse in, we're looking for that signal to bounce back, and this is our duration. So depending on how long it takes for that signal to come back. So we're turning that pin on and listening for that signal bounce back. Trigger is just sending out a sound, echo is listening for that. And our distance is duration divided by 58.2. Kind of a standard setup there for the sonar. So we've got our all-important distance. So all this code is doing is giving us a distance. Then we've got a series of if statements here, checking, okay, what is that distance? So first, if the distance is greater than or equal to the low range, which is 0,
and it's less than or equal to the medium range. So medium range is what we set up here is 25. So if the distance is between 0 and 25, then we're going to call this function too close. So what is that function? Well, down here, too close function, it's basically turning on the buzzer and turning off the buzzer with a delay of 100. So we're getting on, off with a short delay. It gives that quick buzzing sound, on, off, and that's our signal that you're too close. So the faster the buzzer is beeping, the closer you are. So this first if statement, if it's between the low range and medium range, then you're too close. That will turn the buzzer on and off quickly. And the next one, if you are between the medium range and the second medium range, so it's a little bit further away, then we're going to have this kind of a strange name, but too medium. And too medium, if you have a look, they're pretty much the same thing, and the only thing that's different is the delay. This is an important number that you might want to play around with. So the delay is slightly longer, so we get a slightly slower buzzing sound. Faster the sound, that's kind of a signal, okay, you're really close now. Slower, then you know, okay, there's something in the way, and that's why we've used 300. And finally, if we're between this second medium range and the long range, so there's something, but it's still quite a way off, then we're calling this too medium 2 function. And again, it's basically the same thing with a longer delay. So we've got a delay of 600. So these three functions are just the parts controlling the buzzer. The shorter the delay, lower this number, the quicker it will buzz. And if something is a bit further away, delay is a bit greater, so it will be buzzing more slowly. That's what gives you the signal. Now, if you've used the game, then this will make more sense. If you haven't used it yet, then once you've used it, this part of the code is going to make a lot more sense. So if you're confident, then you could even add in another range. So we've got 3 at the moment. We've got the long range, medium 2, medium. So there's 3 distances and 3 kinds of buzzing going on. You could add another one that's much slower, or if you're really, really close, it could be really fast. And that would involve adding another if statement and another function changing the delay. So if you feel like a challenge or that something you feel you can do, you could add in another step to it. Or if you don't want to get too involved with changing the code, why not have a go at just changing these numbers here, which will change the speed of the buzzing. Do it, run it, and then that'll make sense. And that's the best way to learn. And the other numbers that you can freely change are these ones here, which will change the distance that it's sensing. So that's a quick overview of the code. And let's move over to seeing what happens when we actually run this.
Right, we're all ready to upload the code. So I'm just going to press upload from the computer. And we should see the lights flashing there. So it's uploaded. Now nothing is blocking the sensor at the moment. I'm going to put my hand to block it. And we can hear it beeping slowly. Now I'm lowering my hand. And it's beeping more quickly. And if my hand is very close, then it's going to beep rapidly. So it seems to be working perfectly, just as Switch managed to do it in the story. But we couldn't possibly give it to Loop at the moment while it's all connected up to a laptop. We need some way of making this mobile, and that's what we're going to do next. So what I've done now is I've actually disconnected this from the laptop, and I'm going to remove the USB cable from the Arduino board.
and we're going to get our power from a 9-volt battery. And to connect the battery we need one of these battery clips. So you can see how these two are going to click together. So we'll do that first. Oops, that way around. And then this is going to go into there. We'll probably get some beeping as soon as it's connected. Okay. Now again, to test it out, I'm going to hold my hand over the sonar sensor and slowly come closer. And we can hear the beeping becomes more rapid. Okay. Now we have something that I can pick up, and we can actually walk around with this because we're not connected to the laptop anymore. So once you've got it in this state, just as Switch did, then it's ready to be delivered to Loop. But what Switch did, she actually connected it up to, it's going to keep on beeping, so I'll unplug it. She connected it to some goggles. So what I've done here is I've taken an old pair of swimming goggles and I've actually painted over the lenses. If you have a look, you can see you can't see through these lenses, and that's just to make it a bit more fun. And all I've done is I've put some tape and some double-sided sticky tape onto there, and the sonar part you can stick down onto the front like that, and the board part I connected with tape onto the side strap there. But there's nothing very technical about doing this or electronic, so I'm going to leave you to figure that out for yourself, and then you've made your very own pair of sonar goggles. So have fun playing with that, and I'll see you in another video soon.